Hi, good day everyone. Welcome to another video lesson in Mathematics Grade 10. And for this week, week 5, and for next week, week 6, we will be talking about secants, tangents, segments, and sectors of a circle and solving problems on circles. So let's have the most essential learning competencies for this week and next week. So illustrate secants, tangents, segments, and sectors of a circle. We're going to prove also theorems on secants, tangents, and segments, and then solve problems on circles. So this module is divided into 3 lessons. So the first one is on angles formed by secants and tangent of a circle. And then lesson 2, secant and tangent segments, and lesson 3, sectors and segments of a circle. This video lesson is all about angles formed by tangents and secants. So wait for the uploaded video lessons on lesson 2 and lesson 3. But before we go on further, let's talk about yung definition ng tangent line. So what is a tangent line? A tangent to a circle is a line coplanar with the circle and intersects it in one and only one point. The points of intersection of the line and the circle is called the point of tangency. So consider our circle here, circle A, and a line LV, and the point of intersection of the circle and the line is point N, only one point. And the point of intersection is what we call the point of tangency. Now, let's talk about theorems related to tangents. The first 3 theorems are stated here without proof. So let's start with the tangent line theorem. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So consider this circle O and the tangent line AB. If a line is tangent to circle O at A, then the angle formed is a right angle. They are perpendicular. Now, let's proceed to the line tangent theorem. The line tangent theorem is the converse of the tangent line theorem. So if line RS is perpendicular to the radius QR, then RS is tangent to circle Q at R. And then the next theorem is the tangent segments theorem. If 2 segments from the same exterior point are tangent to a circle, then the 2 segments are congruent. So in this case, CB and AB are tangent segments and intersect at point B. So CB is congruent to AB. So if this is 8 centimeters, therefore AB is also equal to 8 centimeters. Now, let's discuss common tangent. So let us define what is a common tangent is. A common tangent is a line that is tangent to 2 circles in the same plane. So consider a circle. So let's name it as circle X, and another circle, which is circle Y, and we have a tangent line, line AD, and this line AD intersects circle X at A, and the same line, line AD intersects circle Y at D, then line AD is an example of a common tangent. Also with line CB, it is also a common tangent. To be more specific, it is called common internal tangent if it intersects the segment joining the centers of the 2 circles. As you can see, we have here a dotted line or a dotted segment. If that common tangent intersects that line of centers or the segment joining the centers of the circle, then we call that common tangent as a common internal tangent. When do we say that a common tangent is a common external tangent? If we have a line of centers and that common tangent do not intersect the line of centers, then line AB and line CD are examples of common external tangents. Okay, so now let's define secant line. So a secant is a line that intersects a circle at exactly 2 points. So in our figure, we have here a circle O and a line CA. If it intersects the circle at 2 points, at point C and point A, then line AC is an example of a secant line. And this secant line contains a chord which is chord AC. And now, let's proceed to the main topic of this lesson 1, which is on the theorems on angles formed by tangents and secants. So there are 5 theorems under this. We are going to prove these 5 theorems. The first one is the intersecting tangent and secant on the circle theorem, which states that if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So in here, we have here a circle M with RA as a tangent line and RB as a secant line intersecting at the point of tangency R. We are going to prove that this angle BRA is equal to 1/2 the intercepted arc BR. The intercepted arc BR, that one. Okay, so given circle M with line RA as tangent and intersecting the secant line RB at point R. So we are going to prove that the measure of angle BRA is equal to 1/2 the measure of arc BR. So we are going to prove this using 2-column proof. So the first column are the statements and the second column are the reasons. Yung first step natin, we are going to write the given. So line RA is a tangent intersecting the secant line RB at R. So the reason is given. Then we draw the diameter RC. So we have here yung dotted, as you can see. Yan, dotted segment. So that is, we draw that one. 2 points, reason 2 points determine a line. Then we draw also segment CB, this portion. Again, reason 2 points determine a line. Then, take note that if we draw a diameter and a diameter contains a radius. So, if a radius intersect a tangent line, then they are perpendicular. That is the tangent line theorem. Next, angle CRA then, this one is a right angle. Why? By definition of perpendicularity. Because since these two are perpendicular, therefore this is also a right angle. Therefore, the measure of angle CRA, the measure of this is equal to 90 degrees. That is by the definition of a right angle. Then the measure of angle CBR, so CBR, this one. The measure of that is equal to 1/2 the measure of arc RC. This one, it is a semicircle. The measure of the inscribed angle is 1/2 the measure of its intercepted arc. And since it is a semicircle, then it is equal to 180. Reason, the measure of a semicircle is 180. By step 8, then the measure of angle CBR then is equal to 90 because 1/2 of 180 is 90. So this is equal to 90 degrees. Angle CBR is a right angle. Since 90th measure na, therefore this is a right angle. And triangle CBR is a right triangle. So this triangle is a right triangle. Angle BCR, so BCR, this triangle, angle I should say, this angle, and angle BRC, this angle, are complementary angles. Yes, they are complementary. The reason is that in a right triangle, the two acute angles are complementary. So if we are going to add the measure of these two angles, it is equal to 90 since they are complementary nga. Which means that the measure of angle BRA plus the measure of angle BRC, these two angles, is equal to 90 degrees, and it is equal to the measure of angle CRA. Yeah? By angle addition postulate. So the measure of angle BRA, so angle BRA, this angle, plus the measure of angle BRC, this one is equal to 90. Tama naman. Ano? And then by transitive property, then the measure of angle BCR plus the measure of angle BRC is equal to the measure of angle BRA plus the measure of angle BCR. Nangalantay deta ni 13 ken ni 15 since both of them equal to 90. So pinag-equal tayo suda by transitive property. Therefore, by addition property, we cancel this 2. The measure of angle BCR is equal to the measure of angle BRA. So the measure of angle BCR, asan si measure of BCR? BCR, this angle, is equal to 1/2 the measure of arc BR, this one. So that is the theorem on inscribed angle, that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So we have this. Therefore, by transitive property again of number 17 and 18, since these two are equal and BCR is equal to this, therefore the measure of angle BRA is equal to 1/2 the measure of arc BR. So, ganun yung pag-prove. So, we have already proven that the measure of angle BRA is equal to 1/2 the measure of arc BR. Let's have an example. So, if the measure of arc RB, so arc RB, we are referring to this, that is equal to 150 degrees, then what is the measure of angle BRA? So, BRA, this measurement. Based on our theorem, the measure of angle BRA is 1/2 the measure of its intercepted arc RCB. But we don't know what is the measure of arc CB. But take note that the sum of the measurement of the whole circle, arcs of the whole circle, is equal to 360. So 360 minus 150, that is equal to 210 degrees. So 1/2 of 210 degrees, that is equal to 105 degrees. Ngaro din. Okay? So the measure of that angle is 105 degrees. Now, let's proceed to our next theorem, the intersecting tangents theorem. So, we have two tangents intersecting at the exterior of the circle at point D. It says here that if two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measure of the intercepted arc. What are the intercepted arcs that we're referring here? It is arc REA and then arc RA. So that one. So in here, if we note this as angle 1, so the measure of angle 1 is equal to 1/2 the positive difference of the intercepted arc, the measure of arc, REA, minus the measure of arc, RA. So let's prove this. So given DR and line DR and line DA are tangents to circle M at R and A respectively and meet at D. We're going to prove that the measure of angle 1 is equal to 1/2 the positive difference of arc REA minus arc RA. So first, so number 1, we're going to write the given and then reason given. Next, we connect point R and point A. So we connect that one, draw the chord RA. So 2 points determine a line for the reason. Next one is that the sum of the interior angles, angle 1 and angle 2, is equal to the exterior angle of the triangle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So angle 1 plus angle 2 is equal to angle 3. By addition property, we add negative the measurement of angle 2 on both sides of the equation. So the measure of angle 1 is equal to the measure of angle 3 minus the measure of angle 2. The measure of angle 3 is equal to 1/2 the measure of arc REA. So arc REA. Why? By our previous theorem, which is the intersecting tangent and secant on the circle theorem. So 1/2 the intercepted arc. So the measure of angle 3 is equal to 1/2 the measure of arc REA. Now angle 2, ganun din, the same reason we're going to use the intersecting tangent and secants on the circle theorem. So angle 2 is equal to 1/2 the measure of arc RA. Yan. Then the measure of angle 1 is equal to 1/2 the measure of arc REA minus 1/2 the measure of arc RA by substitution property. Therefore, by distributive property of equality, the measure of angle 1 is equal to 1/2 the measure of arc REA minus the measure of arc RA. So we have already proven that the measure of the angle formed by two tangent lines intersecting outside the circle is equal to 1/2 the positive difference of its intercepted arcs. So let's have an example. If the measure of arc REA is equal to 200, so this is equal to 200 degrees, then what is the measure of angle RDA? So in this case, take note, the sum of this is equal to 360. So if that is 200, therefore this is equal to 160 degrees. So the measure of angle RDA is equal to 1/2 the measure of arc REA minus the measure of arc RA. So 1/2 of 200 minus 160, that is equal to 1/2 of 40, which is equal to 20. Therefore, this is 20 degrees. So we are done with two theorems. Now, let's proceed to the intersecting tangent and secant exterior theorem. Third theorem natin. If a secant and a tangent intersecting in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measure of the intercepted arcs. Sir, parang pareho lang sa previous natin. Yes. Pero for this theorem, isang tangent at isang secant nag-intersect outside. But the same din yung formula niya. It is 1/2 the positive difference of the intercepted arcs. So the intercepted arc here are arc RE and arc RA. So we are going to prove that the measure of angle 1 is equal to 1/2 the measure of arc RE minus the measure of arc RA. So let's prove that one. So given natin, we have line DR as tangent of circle M at R and mid-secant RE outside the circle at D. So yung point of intersection nila at point D. We're going to prove that the measure of angle 1, this angle, is equal to 1/2 the positive difference of the measure of arc RE minus the measure of arc RA. So again, by two-column proof, we're going to write the given. Reason natin, given. Next, we draw yung point of intersection ng tangent, ayan, and circle. So point R and connect it to point E. So reason, 2 points determine a line. Now, by exterior angle theorem, triangle exterior angle theorem, the sum of the measures of the remote interior angles is equal to the exterior angle of the triangle angle 3. So measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3. So by addition property of equality, based on 3, then the measure of angle 1 is equal to the measure of angle 3 minus the measure of angle 2. The measure of angle 3 by the intersecting tangent and secant on the circle theorem, that is equal to 1/2 of its intercepted arc RE. For angle 2, we're going to use yung inscribed angle, that the measure of the inscribed angle, angle 2, is equal to 1/2 of its intercepted arc, RA. So, the measure of angle 1 by substitution is equal to, si angle 3 ay equal dito, 1/2 of the measure of RE. So, we have that. And angle 2, that is 1/2 the measure of RA by substitution. By distributive property, factor out 1/2, then the measure of angle 1 is equal to 1/2 of the measure of arc RE minus the measure of arc RA. Okay, so we are done proving that theorem. Now let's proceed to the application. If the measure of arc RE is equal to 120 degrees, the measure of arc RA is 90 degrees, what is the measure of arc RDA? Ito din. So the same. The measure of angle RDA is equal to 1/2 the measure of arc RE minus the measure of arc RA. So that is equal to 1/2 of 120 minus 90. So that is equal to 1/2 of 30, which is equal to 15. Therefore, this is 15 degrees. Can you follow? Okay. Let's proceed now to Theorem 4. The intersecting secants exterior theorem. We're going to prove that the angle here, angle EDB, is equal to 1/2 the positive difference of its intercepted arc. So let's prove that one. Given secant DE and secant DB intersect in the exterior of circle M at D. We're going to prove that the measure of angle EDB is equal to the positive difference of its intercepted arcs, arc EB and arc RA. So we're going to prove this by two-column proof. So first, write the given and reason given natin. Next, we connect point E and point A. Reason, 2 points determine a line. Then the measure of angle EDB, the measure of this, plus the measure of angle DEA, so asan si DEA? DEA, that one, is equal to the measure of angle EAB. This one. The same, the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Kanina kasi, we name it as 1, 2, and 3. Ganun din ito. And then, by addition, property of equality, so the measure of angle EDB is equal to the measure of angle EAB minus the measure of angle DEA. Now, the measure of angle EAB is equal to 1/2 the measure of arc EB because that is an inscribed angle. The measure of angle DEA, this one, is also equal to 1/2 of arc RA because that is an inscribed angle. Therefore, by substitution, based from number 4, 5, and 6, we substitute. Instead of writing the measure of angle EAB, we substitute it by 1/2 the measure of arc EB. So we have this one. And then instead of writing the measure of angle DEA, we substitute it by 1/2 the measure of arc RA. Then by distributive property of equality, we factor out 1/2, that is the measure of arc EB minus the measure of arc RA, and that is equal to the measure of angle EDB. So we are done proving that theorem. So the measure of angle EDB is equal to 1/2 the measure of its difference of its intercepted arcs. So let's have an example on that. If arc EB is equal to 140 degrees, arc RA is equal to 60 degrees, what's the measure of this angle? Remember, the measure of angle RDA is equal to 1/2 the measure of its intercepted arc, EB, minus the measure of angle, or arc, I should say, RA, that is equal to 1/2 of, what is EB? 140 minus 60. So that will be 1/2 of 80. So therefore, that is equal to 40. So this is now 40 degrees. Okay? And the last theorem, ayan, medyo inhale, exhale. The last theorem is the intersecting seconds interior theorem. So kanina, exterior lahat, difference, positive 1/2 the positive difference of the intercepted arc. Ngayon naman, 2 seconds intersecting in the interior of the circle. And it says here that the measure of angle DXB, this angle, is equal to 1/2 the sum of its intercepted arc and the arc of its vertical angle. So it says here in that theorem that if 2 seconds intersect in the exterior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So prove natin yan. Second, DA and RB intersect in the this should be interior. Interior of the circle at X. Not necessary that it is the center yung X. Ano? And then we are going to prove that the measure of angle DXB is equal to 1/2 the measure of arc DB plus the measure of arc RA. So the measure of arc DXB is equal to the sum of arc DB plus arc RA. So yung given natin, reason, given. We connect our point D and point R. Yan. So 2 points determine a line. The measure of angle DXB is equal to the measure of angle DRB, this one, plus the measure of angle RDA, this one. So, that is the triangle exterior angle theorem. Yung parang kanina yung may 1, 2, and 3. Then the measure of angle DRB is 1/2 the measure of its intercepted arc, dB. So, 1/2 of the measure of arc, dB. By the measure of an inscribed angle is 1/2 the measure of its intercepted arc. And also, the measure of angle RDA, so RDA, eto, is equal to 1/2 of its intercepted arc, RA. So, the same reason. Then, by substitution, substitute natin dyan, and then substitute din natin dyan. So, we have the measure of angle DXB is equal to 1/2 the measure of arc, dB, plus 1/2 the measure of arc, RA. Then, by distributive property, factor out 1/2, that is equal to the measure of arc, dB, plus the measure of arc, RA. Okay, so we are done, and let's have an example. If the measure of arc dB is equal to 40. Ayan, 40 daw ito. And the measure of arc RA is equal to 60. Then what is the measure of angle RMA? So RMA, eto daw. Anong measure nito? So remember that the measure of angle RMA is 1/2 the sum of the measure of the intercepted arc of RA plus the measure of arc dB. So that will be 1/2 of 60 plus 40. So 1/2 of 100. That is equal to 50. So this is equal to 50. If your question is, Sir, equal ba yung angle RMA at saka angle DMB? Yes, this is also equal to 50 because they are vertical angles, and vertical angles are congruent. Okay, so we are done with the theorems, and now let's proceed to the application. Let us answer this one. So, TB is a tangent to a circle O at B. AOB is a diameter. EACT and EFB are seconds. If arc CA is equal to 110 degrees and angle 1 is equal to 25 degrees, find arc AF. Sige. Sabi dyan, si TB daw, this one, and si TB ay tangent. And the point of tangency is kay B. Si AOB, ayan, it is a diameter. So yung diameter, recall that it divides the circle into two semicircles. Si EACT is a secant, also with EFB. If arc CA is equal to 110 degrees and angle 1 is equal to 25 degrees, what is arc AF? Ano daw si arc AF? Wala dyan sa diniscuss natin kanina. But this one is an application of our previous discussion, which is on inscribed angle. So, since angle 1 is an inscribed angle, then the intercepted arc is times 2 of the inscribed angle. So, this will be 50 degrees. So, the measure of arc AF is 50 degrees. Next, number 2. Angle 2. We are going to find angle 2. Si angle 2 ay formed by a secant, this one, this secant, and a tangent. So, we're going to measure this one. Take note that this is equal to 180. This is a semicircle. Why? Because this is a diameter. So, kapag 50 yan, therefore, this is equal to 130 degrees. Tama ba? So, 50 plus 130, 180. And this one is equal to 70 degrees. Why? Because this is also a semicircle, so 70 yan kasi 110 yan. Okay. So, mafa-find na natin si angle 2. Si angle 2 ay 1/2 of the measure of arc AFB, the semicircle, and arc CB, the measure of arc CB. So, 1/2 of 180 minus 70. So, that will be 1/2 of 180 minus 70, that is 110. So, the answer is 55. Therefore, that is 55 degrees. I hope you can follow. Now, let's proceed kay angle 3. Si angle 3 ay ito. Yan. And notice, ito din ay inscribed angle. At ang inscribed angle, half ng intercepted arc. So, since na-find na natin kanina na ito ay 70, therefore, this is 35 degrees. Kasi 70 divided by 2. So, 35 degrees. Next, angle E. Ito, si angle E. Ang angle E natin ay formed by 2 secants intersecting outside the circle. So, ang kukunin natin, ang intercepted arc niya ay arc CB and arc AF. So, that is 1/2 of the measure of arc CB. It is 70 minus 50. That is equal to 1/2 of 20, which is equal to 10 degrees. Okay, so we are done with number 4. And now, sulat ko dito, 10 degrees. The measure of angle ACB. So, ACB. It is also an inscribed angle. But what is so special in this? The intercepted arc is a semicircle. So, since that is a semicircle, then this is a right angle. So, it is a 90 degrees. Next, number 6. Angle ABC. This angle. This angle is also an inscribed angle. So, if that is 110, half of 110, that is 55 degrees. To check if our answer is correct, this is a triangle. If you are going to add all, that is equal to 180. 90 plus 55 plus 35, it is equal to 180. Yes. Next, angle EAB. Angle EAB. So, etong angle na to. If you notice, EAB is a triangle. And the sum of the interior angles of a triangle is equal to 180. So, kapag 10 yan, 25 yan, so that is now 35. 180 minus 35, that is equal to 145 degrees. So, this is equal to 45 degrees. And last, the measure of angle 4. Etong angle dito. Yung first theorem natin on the angles formed by a tangent and a secant, it is 1/2 of its intercepted arc. So 130 divided by 2, that is equal to 65 degrees. So eto na ngayon yung application ng ating theorems. Yan, pinaghalo-halo natin, including yung knowledge natin, an inscribed angle, and the sum of the interior angles of a triangle, which is equal to 180 degrees. And now, mag-application na tayo. So, let's proceed to word problems involving angles formed by secants and tangents of a circle. So, an observer watches people riding in a Ferris wheel that has 24 equally spaced cabins as shown below. Hindi right yan. Shown below. What is the measure of angle X? This is the line of sight of the man, and standing there, and this is the horizontal line in line with the eye level. So that is angle X. And yung mga cabins natin, equally spaced sila. Okay? And there are 24 of them. Now, if that is a circle, and there are 24 cabins, and yung degree measurement ng whole circle is 360, we divide it by 24, then yung degree measure ng 2 consecutive cabins is 15 degrees. Can you follow? Okay. Now, let's just label this para mas concrete yung answer natin mamaya. Yeah, so, let's name this yung intersection nila A, and this is B, and this is C, and this is D. Now, the angle or the angle form is formed by a secant and a tangent. So, X is equal, angle X is equal to 1/2 the measure of arc AD minus the measure of arc BD. Okay. So, 1/2 of, ano yung measure ni arc AD? So, ilang cabins ba yan? So, yung space nila, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 10 times 15, that is equal to 150 degrees. So, ang sum nito, ang degree measure niyan ay 150. Dito, 1, 2, 3, 4, 5, 6. So, 6 times 15, that is 90. Therefore, this is 90 degrees. So, that is now equal to 1/2 of 60 degrees. So, ano yung 1/2 ng 60? So, it is 30 degrees. So, angle X, bakit may degrees doon? May I remove that one? Sige, remove ko yan. Angle X. So, angle X is equal to 30 degrees. Ganun lang yan. Okay, let's have the last example. The geostationary satellite is about 36,000 kilometers away from the Earth. If the Earth is taken a picture from the satellite with a camera lens of 38 degrees field of view, so yung field of view daw nung camera ay 38 degrees, how many arc degrees of the planet are visible to the camera? Ito yung hinahanap natin. So, if we let this as A, B, and C, no? Let's have this as D. Maglagay tayo doon ng D to differentiate yung 2 arcs. Ano yung we're going to find yung measure ni arc AC. Yun yung hinahanap natin. Take note that these two are 2 tangent lines intersecting outside. So the measure of angle ABC is equal to 1/2 the measure of arc ADC minus the measure of arc AC. So, alam natin na yung measurement nito ay 38. Ayan, 38 yan. And 1/2 of, ano yung measure ni ADC? So, if we let this as X, therefore, this is 360 minus X. Tama ba? Etong portion na to ay 360 minus X, and then si AC ay X din. Do you get it? Ulitin natin. Kapag add natin lahat ito, 360. Since linet natin na X ito, therefore, this will be 360 minus X. So, we substitute 360 minus X minus we let the measure of angle AC as x. We multiply both sides by 2. Ayan, 2. So this will be 76. That is equal to, cancel natin yon. That will be 360 minus 2x. We transpose negative 2x. So magiging 2x is equal to 360 minus, transpose natin 76. So magiging minus 76. So 2x is equal to, compute natin, 360 minus 76. That is 284. So, lagay ko dito Divide both side by 2, then ang x natin ay 142 degrees. So, eto na, yung visible sa camera lens ay 142 degrees. Okay? So, that's all. Thank you for listening. Happy learning, everyone. That's all for today, my dear learners. Thank you for listening. Happy learning. Don't forget to answer yung what's more and what I can do in lesson 1. So see you again in our next video lesson. Goodbye.